Okay, imagine there's a really big star, and at some point, it burns out completely. At the end of its life, such a star explodes. That's what we call a supernova. Its core collapses so strongly that gravity there becomes insanely huge. And from that pressure, a point with unimaginable gravitational force is created. This is what we call a black hole. The crazy part is, gravity there is so strong that even light, photons, can't escape. A black hole literally eats light on its way, and only because of this, we can actually see it. A black hole has a kind of border. It's called the event horizon. If you're outside of it, you still have a chance to escape. Like, if you have a spaceship with enough power, you can still get away. But the moment you cross that border, the event horizon, there's no way back. You're doomed to fall straight to the center. But here's the thing. You don't die instantly from this insane gravity. At first, it feels like falling from a really high place. Nothing special, just stronger and stronger gravity. But the closer you get, the more your body begins to stretch. Your head, your arms, your legs, everything starts stretching like spaghetti. This is called spaghettification. You're still technically whole, but your body becomes insanely stretched until it rips apart near the black hole. And here's something terrifying. Because a black hole bends light so much, if you look forward while falling, you might actually see yourself from behind, as if you're watching yourself from the back. Creepy, right? As you keep falling, time itself starts slowing down. For you, everything moves slower and slower, like the world is freezing. Eventually, you feel like you're stuck on the edge, in darkness, until you just fade away. From the perspective of an outside observer, you would simply look like you fell in and vanished. But for you, it's a direct trip to the center. Now, if the black hole is supermassive, like millions of times bigger than our sun, and let me remind you, our sun could fit about 5 million Earths inside it, then you wouldn't even feel that much pain. You'd just slowly stretch and disappear. But if the black hole is small, it will tear you apart way before you even reach the event horizon. Brutal.
And about the core of the black hole, it's not really a core. It's called the singularity. That's the very center, where all the mass is squeezed into an infinitely small point. There, all the laws of physics as we know them completely break down. We have no idea what actually happens inside. Scientists are still debating this, but most agree that once you cross the horizon, all information about you is gone forever. Not a single atom, not a single molecule of your body survives. The only thing left of you would be memories, maybe photos back on Earth, but not you. And about the core of the black hole, it's not really a core. It's called the singularity. That's the very center, where all the mass is squeezed into an infinitely small point. There, all the laws of physics as we know them completely break down. We have no idea what actually happens inside. Scientists are still debating this, but most agree that once you cross the horizon, all information about you is gone forever. Not a single atom, not a single molecule of your body survives. The only thing left of you would be memories, maybe photos back on Earth, but not you. To put it simply, a black hole is a place where gravity is so strong that even light can't escape. And since light, photons, is connected to how we measure time, messing with light means messing with time itself. Which is why, for someone watching you from outside, you look like you're frozen and then gone. For you personally, it's just the end, straight into the singularity. And that's how your story ends. I really hope you found this interesting. Believe me, I spend a lot of time working on these videos. I put a lot of effort in. I'm a real person, not AI. I just have a bad mic and a terrible voice, so I try to make it nicer for you. I hope you enjoyed it. Let me know your thoughts in the comments. Subscribe, leave a like, live an amazing life, and please, don't get too close to black holes. Thanks everyone. Bye-bye.
Our planet will be destroyed, and along with it, you, your family, everyone you know, the whole world, and the entire history of humanity. Because a black hole is moving towards our planet, and none of us will survive. That kind of scary story is something anyone who doesn't know much about black holes might believe. But relax, it's not that simple. I'll try to explain in the simplest words possible what a black hole really is, and whether it's actually a danger to us. So listen carefully and watch what I'm showing you. Let's start with the basics. What is a black hole? In my previous video, I already explained what a black hole is, what the event horizon is, and what singularity means. Now let's talk about the danger itself. Basically, a black hole is like a cosmic monster. And yes, it really is a monster. It's not alive, at least not as far as we know, but still. Black holes are born when a huge, massive star dies. And I'll remind you, a star that is way bigger than our Sun. Our Sun alone could fit up to 5 million Earths inside it. Just try to imagine those numbers. It's insane. Anyway, when such a massive star dies, the explosion creates such intense gravity that not even light can escape it. That's when a black hole appears, and it literally eats everything in its path, including light itself, the photons. And photons, some scientists say, don't even have mass, yet even they can't escape. Now, do black holes fly around space like hungry beasts devouring everything they see? They don't wander like cosmic predators. A black hole just sits there, like a trap, like a snare. Anything that gets too close falls in, but it doesn't chase objects by itself. Remember, space is insanely huge. Distances are so massive, it's almost impossible for us to picture them. Light itself needs millions of years to travel from one star to another. So the chance of a black hole suddenly showing up right next to us is basically zero. And if there was one nearby, we would have noticed long ago.
But how does a black hole actually work? People often imagine it like a gigantic vacuum cleaner sucking everything in. But that's not true. A black hole only pulls things in when they're extremely close. If you replaced our Sun with a black hole of the same mass, Earth would still orbit it in the exact same way. Literally nothing would change, except that we'd all freeze to death because there'd be no sunlight. But that's another story. The main danger is if we actually got too close and got pulled in. So what do scientists say about this? Astronomers constantly monitor the sky. They know where black holes are because they reveal themselves. For example, when they consume gas or dust, the material glows in X-rays. And near us, there are none of them. Our galaxy has millions of black holes, but they're all incredibly far away. Could a black hole ever get to Earth? Theoretically, sure, like any object in space. But the distances are so enormous that even the closest known black hole would take billions of years to reach us. Billions! The Sun will explode and swallow Earth long before a black hole ever gets here. It's like imagining a fly traveling across the entire planet just to land on your hand. But let's say, just for fun, that a black hole did get here. What would happen? Well, first of all, you wouldn't die immediately. Earth would start being stretched apart by its gravity. The near side of Earth would be pulled stronger than the far side. That's called spaghettification. Same thing would happen to you. Your head pulled one way, your legs another. Light itself bends so extremely near a black hole that you could literally see your own back in front of you. Imagine that, looking straight ahead and seeing your back. Creepy, right? But here's the thing, black holes aren't something you should worry about. Honestly, we have much bigger real problems. Global warming, asteroids, nuclear weapons, aggressive Russia. Black holes are far-off cosmic monsters that exist, yes, but they're nowhere near us. So in conclusion, no, a black hole will not eat Earth. They look scary, their power is unimaginable, but in real life, they're so far away that it's practically science fiction for us. So you can sleep peacefully. I hope you enjoyed this video. I'm a real person. I just have a crappy mic and a terrible voice. That's why I put extra effort into making it nice for you to listen to. I hope you found this interesting. Please leave a like, subscribe, find yourself a beautiful partner, and live a happy life. God bless you all, goodbye, and good luck.
You won't survive the next night because a black hole will devour you, and all the information about you will simply disappear. You won't die. It's just that every single piece of information about every atom of you will vanish forever, as if you never existed at all. Not even a single atom of you would remain. That's what would happen if you fell into a black hole. But let me explain in more detail what I mean. So, what exactly are black holes? They're not science fiction, not myths, not scary bedtime stories. They are real physical objects that exist in our universe, somewhere far away in space. And they carry great importance. Honestly, they might be one of those things that completely break the laws of physics. Listen carefully. Black holes are regions of space where gravity is so strong that even light cannot escape. They can form from the gravitational collapse of massive stars or from the merging of other cosmic objects. Even though we can't see them directly, we can observe their influence on nearby space. The motion of stars, the X-ray radiation from hot gas, or gravitational waves.
So yes, we literally cannot see a black hole. It's like how you can't see the vortex inside a tornado. You only see the debris swirling around it. And from that, you know something terrifying is inside. The same goes for black holes. They're basically a point with an incredibly strong gravitational field, a gravitational anomaly, if you will. What do scientists say about them? In 1965, mathematician Roger Penrose proved a theorem showing that under certain conditions, Einstein's general theory of relativity predicts the formation of singularities. These are the points where spacetime itself breaks down, where curvature becomes infinite. You heard that right. You don't need the infinity stones, because in real life, such an object actually exists, and it's called a black hole.
When Penrose published this, it was revolutionary. Before that, people thought singularities were just mathematical artifacts or flaws in equations. But Penrose showed that they could form naturally, literally, through the process of gravitational collapse. Sounds scary? Hold on. Later, another scientist, Stephen Hawking, combined this with quantum physics and showed that a singularity isn't just a meaningless mathematical point where matter collapses. It's a real physical anomaly in our universe. Meaning, good old Newton might have been wrong about some things after all. But never mind that. Let me explain it differently. Imagine a spring. You keep compressing it tighter and tighter, until at some point it stops being a spring and just snaps. In mathematics, a singularity is a similar kind of breaking point, where all our physical laws tear apart.
In 1974, Stephen Hawking introduced one of the most unexpected ideas, that black holes aren't completely black. He proposed that quantum fluctuations of energy can occur at the event horizon, causing one particle of a pair to fall inside while the other escapes outward. This phenomenon is called Hawking radiation. Through this, Hawking showed that black holes can actually lose mass, slowly evaporating over time, though extremely slowly. And even though we can't directly observe it, because our eyes simply aren't made for that, it's a real process. It's like air. We can't see it, but it's always around us. Imagine a sealed black box leaking gas ever so slightly, so slowly that you'd never notice until it's completely empty. And what about the information paradox? If information about matter falls into a black hole, does it disappear forever? Quantum physics says no. Information cannot be destroyed. That creates the so-called information paradox. A new idea being discussed today, the island formula, suggests that part of that information could be preserved in the form of quantum entanglement, even if the matter itself is gone. So, when you fall into a black hole, you don't exactly die. You just stop existing for the outside world. Inside the black hole, time freezes for you, and all the information about you remains trapped within. If the black hole is massive enough, larger than our sun, you wouldn't even feel pain or notice anything. It would be like entering a frozen state. Recent studies, like the 2023 Radboud team's research, suggest that black holes may evaporate not only through Hawking radiation, but also due to the curvature of spacetime itself. And now scientists are trying to unify quantum gravity with general relativity to understand what truly happens inside these cosmic monsters.